if a system is already in equilibrium and we apply any external stress on that, the system will itself shift accordingly to nullify the effect. When the temperature is increased, the system will favor endothermic reaction to nullify that effect. It will be opposite to each other. If we are increasing the pressure, what will the system try to do? It will try to decrease the pressure. So how it will try to decrease the pressure? By decreasing the number of moles. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today we are back with session 4 of the chapter Equilibrium. So in the last session we discussed about the derivation of Kp, right? Derived Kp expression for gaseous reversible homogeneous reaction, right? And the relationship between Kp and Kc was also discussed, which is a really important equation, right? As well as the different applications of equilibrium constant were discussed. And also the relationship between equilibrium constant, reaction quotient and Gibbs free energy was discussed in the last session. So in today's session, we are going to study about the different factors which is affecting the equilibria. So to begin with, there is a very important law which we have to study, based on which we have to understand the different factors on which the equilibria will affect. So that principle is called as the Le-Chatelier's principle, which is a very important principle. So let's see. When external stress is applied on a system at dynamic equilibrium, the system shifts the position of equilibrium so as to nullify the effect of stress. Okay, so what does this sentence mean, or what does this principle mean? So let us assume that a system is already in equilibrium. Okay, so it has already attained dynamic equilibrium. Okay, so now if we are applying any stress on it, so the stress can be in the form of change in concentration. We can change the concentration, we can change the temperature, we can change the pressure. Okay, either we can add a catalyst, either we can add an inert gas. So such kind of stress is applied onto a system which has already attained equilibrium. Now what happens if the stress is applied? Yes, of course the equilibrium will shift now, right? It will not be attained in the same position because we have changed the conditions, either the temperature or concentration we have changed. So now what happens is the system itself will shift accordingly so that it nullifies this effect. So what happens is, for example, if we are increasing the concentration of either the reactants or products, the system itself will try to nullify that effect. So for example, if we are increasing the concentration of the reactants, what will happen? Yes, it will try to reduce the concentration of the reactants. The system will try to reduce the concentration of the reactants so that the shift will be nullified, or the effect will be nullified. So how can you decrease the concentration of the reactants? Okay, so what does it actually mean? If let's assume that we have reactants, some reactants which is giving us some products. Okay, so what happens is, if we are increasing the concentration of the reactants, okay, now it was already in equilibrium, we are disturbing the equilibrium now. So what does the system try to do? It will try to nullify this effect. That means it will try to reduce the concentration of the reactant. So how can it reduce the concentration of the reactant? By favoring the forward reaction, right? So by favoring the forward reaction, what happens? More amount of reactants will get used up. More products will be formed. So eventually what happens? The concentration of the reactants will get reduced. Okay. So this way, for each factors we are going to discuss. That is for how it is going to affect in terms of concentration, temperature, pressure, catalyst and inert gas. All of this we are going to discuss in this session. So I hope what is Le-Chatelier's principle is clear for you. So if a system is already in equilibrium and we apply any external stress on that, the system will itself shift accordingly to nullify the effect. Okay, so let's see. If the system at equilibrium experiences a change in concentration, temperature or total pressure, okay, the equilibrium will shift in order to minimize that change and a new equilibrium will be established. Okay, so the system itself will shift in a way so that to nullify this effect, right? So first let us discuss the effect of concentration. So if we are changing the concentration, what happens to the equilibrium? Let's discuss. Okay, so when reactants are added to a system at equilibrium, the system tends to decrease the concentration of reactant to convert it into product. So forward reaction is favorable and equilibrium shifts to the right side. So this is what we were discussing in the first slide, right? So let's say we have reactants and it gives some products. Okay. So as told here, when reactants are added to a system, so what we are doing, we are increasing the concentration of the reactants. The concentration of the reactants we are increasing. So what will the system try to do? Now it wants to decrease the concentration of the reactants to nullify the effect. So how can it decrease? By favoring the forward reaction. So by favoring the forward reaction means the reactants will get used up. Right, the reactants will combine much more faster and it will form more amount of products. That means that we can say that when we are increasing the concentration of the reactants, forward reaction will be favored and more amount of product will be formed. Clear? Now let's take the opposite condition. When products are removed, right, when we are decreasing the concentration of the products, when products are removed from a system at equilibrium, the system tends to increase the concentration of the products by converting reactants into products. So again, forward reaction is favorable and equilibrium will shift to the right. Okay, so in that way also we can consider if we are reducing the concentration of the products. Okay, now the concentration of the product, we are decreasing it. So now what will the system try to do? It will try to increase the concentration of the products, right? So how can you increase the concentration of the products? Yes, more amount of reactants has to combine and form products. So what will happen? The concentration of the products will increase. So for that to happen, again, which direction will be favored? Yes, forward direction will be favored, right? Again, the equilibrium will shift from left to the right. Okay, so how we can consider the effect of concentration? Yes, when the reactants concentration it is increasing, to decrease that it will proceed in the forward direction. Okay, so I hope it is clear. So let's take an example. Consider the equilibrium of hydrogen and iodine combining to form hydrogen iodide in a closed container at constant temperature. We are only changing the concentration, the temperature will remain a constant. So H2 plus I2 giving 2HI. It's a balanced chemical equation, right? So if H2 is added to the reaction mixture, now what we are going to do? We are increasing the concentration of hydrogen here. That means more amount of hydrogen we are adding at equilibrium. Then the equilibrium of the reaction is disturbed. Right, now the equilibrium is disturbed. Right, so before reading on to the paragraph, let's see. When hydrogen is, the concentration of hydrogen is increasing, what is the system try to do? What is the tendency of the system? To decrease the concentration of hydrogen, right? So to decrease the concentration of hydrogen, what can happen? Yes, more amount of or more quantity of hydrogen has to react with iodine to form hydrogen iodide. Right, so which direction will be favorable? Yes, forward reaction will be favorable. So in order to restore it, the reaction proceeds in a direction wherein H2 is consumed. So in which direction H2 will be consumed? Reactants has to combine and form products. That means forward direction will be favorable. So that is more of H2 and I2 react to form HI, and finally the equilibrium will shift in right direction. That means forward direction. So this is in accordance with Le Chatelier's principle. Okay, so in case if HI is added, now we are going to add more concentration of products. If the concentration of the products we are increasing, now what will happen? Yes, now the system will again tend to decrease the concentration of products, right, to nullify the effect. So in which direction the system has to, or the reaction has to proceed? It will be favored in the backward direction, right? So more amount of products will get consumed and it will form back the reactants, right? So in case HI is added to the above equilibrium, backward reaction is favored. A portion of added HI decomposes to give H2 and I2 and new equilibrium will be attained. Okay, so if we are increasing the concentration of the products, it will tend to favor the backward reaction. Okay, so I hope it is clear. The next one is effect of temperature. So when temperature of the system is increased at equilibrium, the system tends to decrease the temperature by absorption of heat. So endothermic reaction will be favored. So first of all, what is endothermic reaction and exothermic reaction? In exothermic reaction, yes, heat will be released, right? And in endothermic reaction, heat will be gained. So, if we are increasing the temperature means now the temperature is more, the heat has increased. So, the system will try to attain, or the system will favor which kind of reaction then? Endothermic reaction, right? So that it will consume this heat and decrease the temperature. So, I hope it is clear. When the temperature is increased, the system will favor endothermic reaction to nullify that effect. It will be opposite to each other. Now, let's consider in the opposite way. The temperature is decreased. Now, if the temperature is decreased, what will the system try to do? It will try to increase the temperature, right? To increase the temperature, what it will do again? Yes, it will favor exothermic reaction. Okay, so let's see this. When temperature of the system is increased at equilibrium, the system tends to decrease the temperature by absorption of heat. That is, it favors endothermic reaction. Now, when the temperature of the system is decreased, if we are decreasing at equilibrium, the system, what the system will try? The system will tend to increase the temperature. Okay, the system will try to nullify the effect, right? So, it will try to increase the temperature and it will favor exothermic reaction. So, I hope it is clear. Let's take an example. Effect of temperature on equilibrium can be demonstrated by taking NO2 gas which dimerizes into N2O4 gas. Okay, so 2 molecules of NO2 will combine or dimerize to form N2O4. So, this reaction we are considering. So, the forward reaction, as you can see, the enthalpy is given here. The forward reaction is an exothermic reaction and the backward reaction is an endothermic reaction. So, in this equilibrium, forward reaction is exothermic and backward reaction is endothermic. Okay, so it is already given, forward reaction is exothermic, backward reaction is endothermic. So, let us assume that we are increasing the temperature now. To the system which is already in equilibrium, we are going to increase the temperature. So, what will the system try to do? It will try to decrease the temperature by favoring, yes, endothermic reaction. So, now which direction was endothermic? Forward reaction was exothermic. Backward reaction was endothermic. So, now the reaction will proceed in the backward direction. That means the backward reaction will be favored when the temperature is increased. Okay, so when temperature is increased, to oppose the increase in temperature, the system favors endothermic reaction. Okay, so which side was the endothermic reaction? It was the backward direction. Therefore, when the above system is heated, decomposition of N2O4 is favored and equilibrium is shifted towards the left. Okay, now let's take the opposite. When the temperature is decreased, the system will try to increase the temperature. That means it will favor exothermic reaction. That means the equilibrium will shift to the right. That means it will favor forward reaction, right? So, when temperature is decreased, to oppose the decrease in temperature, the system favors exothermic reaction. That means when the above system is cooled, dimerization in NO2 is favored and equilibrium is shifted to the right. Okay. So, now let's move on to the next one, that is effect of change in pressure. So, if pressure of a system is increased at equilibrium, the system tends to decrease the pressure by decreasing the number of moles. So, equilibrium shifts to such side. So, what is happening here? When the pressure is increased, volume will decrease, right? When we are increasing the pressure, what will happen? Yes, the volume will decrease, right? So, based on this, if pressure of the system is increased, the system will tend to decrease the pressure. Okay, if we are increasing the pressure, what will the system try to do? It will try to decrease the pressure. So, how it will try to decrease the pressure? By decreasing the number of moles. By decreasing the number of moles, so equilibrium will shift to the appropriate side. So, if pressure of a system is decreased, now we are decreasing the pressure at equilibrium. The system tends to increase the pressure by increasing the number of moles. So, equilibrium will shift to such side. So, for example, we are taking carbon monoxide reacts with hydrogen to form methane gas and water vapor. Okay, so you can see here the number of moles is 1 here and 3 here. So, total number of moles of reactants is 4 and total number of moles of products is 2, 1 here and 1 here, right? So, let's see, when pressure is increased, now we are increasing the pressure. We are increasing the pressure, what happens to the volume? Volume will get decreased, right? So, volume will get decreased and it will favor the reaction in which there will be decrease in number of moles, okay? So, in which direction there will be decrease in number of moles? That will be the forward reaction, right? Hence, what happens? The equilibrium will shift to the right. That means it will favor the forward reaction, right? In the above reaction, forward reaction involves decrease in number of moles and hence increases in pressure favors forward reaction and equilibrium will be shifted to the right. Okay. Now, when we are decreasing the pressure, what will happen if we are decreasing the pressure? What happens? Yes, the equilibrium will shift into such direction where there is increase in number of moles. So, in which direction there is increase in number of moles? It is the backward direction, right? So, what happens? The equilibrium will shift to the left. Okay. So, it favors backward reaction and equilibrium shifts to the left. Okay. So, when there is increase in pressure, the equilibrium will shift to the direction where there is decrease in number of moles. And when we are decreasing the pressure, the equilibrium will shift in the direction where there is increase in number of moles. Okay. So, I hope that is clear. Now, the next one is effect of catalyst. Catalyst has no effect on the position of equilibrium because it alters both forward and backward reactions to the same extent, but equilibrium attains quickly. So, this we have discussed in the beginning of this chapter as well, the effect of catalyst. So, what is the use of a catalyst? It is used to increase the rate of the reaction, right? So, it doesn't actually have any effect on the equilibrium. It just helps in attaining the equilibrium quickly, but it will be attained at the same point itself. There will be no shift in the position of the equilibrium, only that it will be attained quickly. Now, why is that happening? If we are adding a catalyst to a reaction, it will have an effect both on the forward reaction as well as the backward reaction equally. So, eventually what happens? It is having an equal effect on forward reaction as well as backward reaction means it will have no effect, right? So, that is why if you are adding a catalyst also, there will be no shift in the equilibrium. It will be just that the equilibrium will be attained more fast or more quickly, right? Now, the next one is effect of rare gas or inert gas. So, addition of inert gas at constant volume does not change the partial pressure or molar concentration of the substance involved. So, the added gas does not take part in a reaction. Therefore, addition of inert gas has no effect on position of equilibrium at constant volume. So, again, it is inert gas. Inert gas means, of course, it is not taking part in the reaction itself. So, even if we are adding an inert gas to it, there will be no shift in the equilibrium. So, I hope that is clear. So, there is no effect on equilibrium. There is no effect of addition of catalyst or inert gas on equilibrium. So, let's summarize what we have discussed now. The first one is effect of pressure. So, increase in pressure increases the rate of forward reaction since it is accompanied by decrease in number of moles of gaseous reactants, right? Hence, equilibrium shifts to the right side, decrease in pressure increases rate of backward reaction. So, how can you say that? When the pressure is increased, the equilibrium will shift in a direction where there is decrease in number of moles and vice versa, right? The next one is effect of concentration. So, increase in concentration of the reactants, increase in rate of forward reaction, right, to nullify the effect. And addition of ammonia or decrease in concentration of reactants increases rate of backward reaction. So, if we are increasing the concentration, what happens? It will increasing the concentration of the reactants we are increasing, it will favor the forward reaction, right? It will favor the forward reaction if we are increasing the concentration of reactants, right? Now, last one is effect of temperature. Increase in temperature increases the rate of endothermic reaction, that is backward reaction, and decrease in temperature increases rate of exothermic reaction, that is forward reaction. So, if temperature is increased, what will happen? It will favor endothermic reaction, right? It will favor endothermic reaction, and if the temperature is decreased, it will favor exothermic reaction so as to increase the temperature. So, basically, it is all based on Le Chatelier's principle. That means that if there is a stress applied on the system which is already in equilibrium, the system itself will shift accordingly to nullify this effect. So, when the pressure is increased, the system will try to decrease the pressure by increasing the number of moles. Okay. So, this is a very, very important part of this chapter. So, in the next session, we are going to study another important part, that is ionic equilibrium. So, I hope the concepts that we have covered in this session is clear for you. So, that's all for today. Thank you.